Alright, so in this problem what we want to do is we want to write an equation for this table of values. So we know this is the x-intercept, so we know x equals -2, and this is an x-intercept and x equals 5. And we know that this is the y-intercept, which is the y-intercept equals 10. So now what we want to do is we want to kind of think about what's our graph going to look like. So we know -2, 0 is here, and then 5 zeros over here. And we know that 0, 10 is way up here. So this is the y-intercept. So because the y-intercept's up here, we know that the quadratic has to come down like this, just by the points that we know. So that tells you that a has to be -1. Alright, so what I always do is I like to work backwards. So if we know x equals -2 and x equals 5, then if I move it to the other side, x equals -5 equals 0, and x equals, oopsie, bring the -2 over, +2 equals 0. And so then we know this equation equals 0 at x plus 2 times x minus 5 equals 0. And just by looking at the points, we know that a has to be -1. And so our equation would look like y equals negative x plus 2 times x minus 5. And we could write it, that's in factored form. We could multiply those. And so x plus 2 and x minus 5, so that's x squared minus 5x, 2x, and then -10. So we could also write it as y equals negative x squared minus 3x minus 10. So factored form and standard form. Now I wanted to show you another way to get a. So when we got to x plus 2 and then x minus 5 equals 0, we know that there's an a value in front. Typically a lot of the problems we work with, we assume a is 1, okay, but you can't always make that assumption. So if you want to find that value, what we can do is change 0, and so make an equation x plus 2 and then x minus 5 equals y. So then we have an x and y values. So then what you can do is pick a point on your graph. Now you can pick any point you want. The easiest is a lot of times to pick a y-intercept. So if I pick 5, 0, I've got x and I've got y. You plug it into your equation. So you have a times 5 plus 2, and then 5 minus 5 equals 0. And so then we get 5 plus 2 is 7. 5 minus 5 is 0. Okay, so 0 is not a good choice, right? So when you put in 0, this is going to end up being 0. So we need 0 is not a good choice. It's not incorrect, but it's not giving us what we want. So I'm going to pick the y-intercept. So the y-intercept should work. And so I'm plugging it into x plus 2, x minus 5 equals y. So what I'm going to do is I'm going to use 0, 10 to find a. So when I plug that in, I'm going to get a times 0 plus 2, 0 minus 5 equals 10. So then this ends up being a times 2 times negative 5 equals 10. And so then negative 10, a equals 10, and then a equals negative 1. Which some of you guys are going, well, Miss Fifield, we already found that. So, but that's because when we looked at the graph, we could find it just by looking at where the points are orientated, and we knew that a would have to be negative. But it could have been negative 2, it could have been negative 3. I suppose we could have looked at the coordinates to see if it was 2 times or 3 times. But we can also do it algebraically by using the factored form and using a point on the graph. The only thing is we can't use our zeros because it doesn't give us the results that we want.